All right, everyone, good afternoon. Thank you for coming to class today. Let's hold on 1 second. All right. Another day, another lecture. Today is Monday, February 8th. Let's start off with some announcements. I think the announcement I want to make to you guys is concerning next Monday. Next Monday we will have our first exam. So Test 1 is going to be next Monday. It's all online. I will have class, but you're going to have to work from home or at your dorm. And it's going to cover chapters 11 and 12. So there's a multiple choice portion that is going to be next Monday. I'm opening it up the whole day, from 12 a.m. to 12 midnight, so come in any time and do the 20 or 25 or so multiple choice questions. If you have internet issues, text me. I can vouch I have terrible internet at home, so I understand that. So multiple choice is going to be opened up next Monday. And then there's a written portion, problem set. Okay, that's also due next Monday, and I'm opening that up this Friday. So you can go this Friday, especially those that are watching a recording of this. This Friday you can do that and upload it on Monday. So again, this problem set, you need to show your work for partial credit and all of that stuff. All right, so the total is about 50 points. Having said all of this, there's a study guide on Canvas that will tell you what's on the exam. All right, so check out the study guide on Canvas. I think sort of like a laser will tell you what's on the test. And I think that's the big news concerning next Monday. Study guide on Canvas. Oops, study guide Canvas. I'll have office hours on Sunday, the 14th. I'll be at home or in my office, whatever it may be, but we'll be through Zoom. Okay. Zoom, it won't be face-to-face just because of what's going on in the world. So Zoom, office hours, and I think I have it for 5 to 8 p.m. Okay, I think I have it from 5 p.m. to 8 p.m. so you can do that. I'll give you the Zoom link. Will be given later. Okay, so that's the night before the exam. If something on the study guide you don't get, you can see me Sunday night from 5 to 8 p.m. Again, it's not mandatory. I don't have any special lecture. It's nothing special, just for questions or comments. All right, continuing on with housekeeping. So just a heads up about next Monday. Test, it will be on Canvas. The problem set opening up this Friday. Download it, do it, put it on Canvas Monday, and that's the big thing for next Monday. And next Monday we will have class. Just want to repeat that. Also, the way my system works is that the quizzes are due the same day as the exam. So quiz 1 will be due next Monday. So make sure you're working on quiz 1 incrementally, gradually, and all of that stuff. Another thing I want to tell you guys is that please turn in your lab report this Friday. Okay, lab report due this Friday, so I can get you some lab points. Lab report due this Friday. And the lab that we did was intermolecular forces, right? So intermolecular forces. And this Friday we will have another lab, and that's on freezing point depression. We're going to split you up, the class up into, I believe, 8 and 8. So I have the rosters here. It really doesn't matter. You can go to this Friday's lab or next Friday's lab. I just did it by the alphabet. So before you leave, you can take it. Again, you're not obligated to be Group A. If you want Group B, be Group B. If you're Group B and want to be Group A, have at it. So just pass it out. Right. Again, the only criteria is that there has to be 8. Okay, and I think last Friday we had 7, which was a very good number. So I was very happy about that. 7 people came and did the lab, and I think that's really good. And so this Friday will be freezing point depression. Okay, and this is one of those really hard labs of Chem 2, but I think it's all right. A little bit of difficult Chemistry 2 labs will make us only stronger at the end of the day. That's supposed to be a joke, but nobody's laughing. And my final announcement for you guys is turn in homework 12. Homework 11, I think it's past due. Now's the time for really you guys to upload and turn in homework 12, and I'll put in those 10 points. I want them to be due the week after. Yeah, the week after. Obviously, you do have a 2-week window, so if you don't do it the next week, you can turn it in the following week. But I really prefer the week after. But I'm not going to penalize you because of the situation we're in with this virus. And I think a lot of student athletes have talked to me on Zoom that there's some issues and quarantining, and they're quarantining to actually, protect us, if you think about it. So, yeah, next week, but if not, the following week. Any questions? This is a lot on our plate. Next Monday's the big day. Quiz, lab report, upload your homeworks. Study guide on Canvas will tell you what's on the exam. All right, questions or comments? I may not be in this Friday's lab. I have a meeting with some North Carolina something, and so Larissa will probably handle the lab. Okay, so just give her, I know you will, you all are great students, I've had you before, just help her out, and she should know how to do it, because we filmed the labs together. Okay, so let's go to the next page here. I'm going to move on to page 11. So here are some problems that are going to be on the exam, the written exam, and as well as perhaps some multiple choice. So let's go ahead and do some example problems. So a problem like this on the exam. Where we are at here is we're talking about the colligative properties, 2 of them, and the 2 of them are freezing point depression, this Friday's lab, freezing point depression, and boiling point elevation. So this is a problem set that's dealing with that. So let's go ahead and work on this. Okay, so what is the boiling point and freezing point of 478 grams of ethylene glycol and 3,202 grams of water? The molecular weight of ethylene glycol is 62.07 grams per mole. Okay, so let me give you the structure of ethylene glycol. Okay, this is not, you don't need this to solve the problem, but ethylene glycol looks like this. HO, CH2, CH2, and then an OH. So this is the structure of ethylene glycol. Just have a question, okay, off the beaten track. What do you guys think? Do you think this is miscible in water or not miscible in water? Those of you that said miscible are correct. This is miscible, right? Okay, OHs. This can also hydrogen bond. Water can hydrogen bond, so yes, this is miscible. All right, back to our problem here. So we need the boiling point and freezing point. All right. Let me draw this problem out. Okay, I'll draw this problem out, and then we'll get to the numbers. All right. So here's what we have. Okay. So here we have situation 1. We have 3,202 grams of water. Okay, there's our water. By the way, the density of water is roughly 1 gram per mil. So really, we also, in another way of saying it, is it not so? We have 3,202 mils of water. And we know just by life circumstance that the freezing point of water is 0 degrees C, and the boiling point of water is 100 degrees C. Okay, this is just water by itself. I'm just drawing this problem out. Now we've done something here. What have we done? Now, not only do we have 3,202 grams of water, but we also now have added 478 grams of this ethylene glycol. The question is, what is our freezing point and what is our boiling point? So here's the equation that you will use. I'll give this on the exam. So let's first do the boiling point. Okay, new boiling point. The new boiling point, delta TB, is equal to this constant KB times molality, small m. All right, a couple of things here. M is molality. Moles of solute over kilogram of solvent. Okay, we call that molality. Right, this Kb is a boiling point elevation constant. Boiling point elevation constant. Okay, let's look that up here on page 10 for those of us following the notes. Obviously, I'll give you the constant. You don't memorize it. We're dealing with water. So the Kb is 0.52. Take a good look at the units here. I ask you to take a look at the units as being degree C over small m molality. Again, given to you on the exam. I'm going to move back now. So Kb here is 0.52 degrees C over molality, small m. All right, I think we have everything to plug it into this equation. Do we? I think we do. Okay. So molality is mole solute over kilograms of solvent. Let's identify our solute and solvent. Okay, I want you to, if you see a water, I just want you to, like a snap of your fingers, realize that, 99% of the time it's going to be the solvent. Okay, and definitely in this class, which means by default our solute is this ethylene glycol. All right, kilogram of solvent. All right, so we have 3,200 grams of grams of water. Let's go ahead and convert that to kilograms. Okay, which is our solvent. So you guys know how to do this conversion. Okay, maybe it's worth memorizing. 1,000 grams is 1 kilogram. Okay, get that to your memory. And so we move the decimal place 3 to the left. 1, 2, 3. So we have 3.202 kilograms of water, which is our solvent. We got that in orange. So our moles of solute, let's go ahead and convert the 478 grams of ethylene glycol to moles. So moles of ethylene glycol equals, we got 478 grams of ethylene glycol. I'll just write it out. Times, for every 1 mole of ethylene glycol, uh, 62.07 grams of ethylene glycol is in 1 mole. Okay, remember we just add the numbers from the periodic table to get the molecular weight. Right, the grams of ethylene glycol cancels with the grams of ethylene glycol. Right, on my calculator, I'm getting, you can double check my math, I'm getting about 7.70 moles of ethylene glycol. Right, so let's box this in pink. I think we can solve for molality now. I'll do it up here. Okay, small m molality is moles of solute, which is 7.70 moles. Our solute is ethylene glycol. Our kilogram of solvent is 3.202 kilograms. And just double check my work, but I'm getting, get rid of that, 7.70 divided by 3.202, I'm getting about 2.405 small m. Don't forget, okay, small m. Molal, 2.405 molal. Okay, so that's going to go right here. And KB, I think we found KB to be this, 0.52 degrees C over m. Okay, so now we have everything we need to solve this problem. So let's go ahead and do that. Delta TB is going to be 0.52 degrees C over small m molality times molality, which is 2.405 small m. The small m molality cancels with the small m molality. And I'm getting 1.25 degrees C. You got that, Joshua? All right, this is not your answer. Okay. Okay, is our boiling point going to be 1.25 degrees? What is our boiling point? Boiling point elevation. So what do we need to do with that 1.25 degrees? Add it or subtract it? Boiling point elevation. Add it. So our new boiling point, the minute we add 478 of this to 3202 of water, the new boiling point is going to be, this is where people miss, based on my experience here. I've been here for 6 years. They just stop right here. Students stop right here. Okay, you got to write the new boiling point. They do everything right and they stop right here. The new boiling point elevation is 100 degrees plus 1.25 degrees. The new boiling point is 101.25 degrees C. And that is the right answer for your boiling point. All right. Finally, we'll do the freezing point. So let's now talk about the new freezing point. Let's do this in, let's just do this in blue. No, yeah, blue. All right, let's do the new freezing point here. And it's going to be delta TF equals KF times molality. Again, I'll give you this equation on the exam, and I will also give you KF. So let's all go back to page 10 for those following in our notes. Water is our solvent, and I'm getting KF of 1.86. Again, I'll give this to you. You don't need to memorize that, obviously, never. 1.86 degrees C over small m. All right, I think we can solve for this. Case of F is 1.86 degrees C over small m. Molality, didn't we just calculate molality? Right? Isn't it 2.405, Joshua and everyone? We just calculated this, right, Courtney, right? Well, right, everyone. 2.405 is our small m. So small m, cancel. What are we getting here? I'm getting 4.47 degrees C. Is this our answer? Again, many students do this like before. They stop right here, and everything is perfect, but they just leave it here. No. Okay, our new freezing point is not 4.47. What is it? Our new freezing point will be higher or lower? Freezing point depression. Lower. Our new freezing point is going to be 0 degrees minus 4.47 degrees C, and the answer is minus 4.47 degrees C. That's the answer. Okay, because it goes down. Your original freezing point was 0. Freezing point depression tells you it goes down, right? So this is our new freezing point. Minus 4.47 degrees C. This is the basis for antifreeze. You guys know antifreeze? All the ethylene glycol is antifreeze, so it doesn't freeze. All right. New freezing point. Let's write this down here. Minus 4.47 degrees C. Okay. And that's the answer you want to give on a similar problem on the exam. All right, so a problem like this on the test, and I think in the end of this chapter we have some practice problems with the solutions worked out. You can check that out as well. So something very similar to this on the exam. Okay, so I'm going to move on now. If everyone is okay, let's move on to page 12 of our notes. All right, come on. But sometimes that blurriness is how I see things without my glasses. So, all right, here's another problem. So, variation of the theme. Let's work on it together. 2 grams of an unknown compound. Unknown reduces the freezing point of 75 grams of benzene from 5.53 degrees C to 4.90 degrees C. Okay. So what is the molar mass? So molar mass is going to be in units of grams per mole. What is the molecular weight or molar mass of this unknown compound? Okay. So let's take an inventory here. Our solute what is our solute is unknown. Okay, what is our solvent? Don't say water. What is our solvent? Benzene. Very good. Okay, benzene, if you remember, is C6H6. Okay, hydrocarbon, all that stuff. Non-polar dispersion forces. All right, so I'm going to highlight here freezing point. So this is the equation we're going to use. Delta TF is equal to K sub F times molality. So, it's worth noting, what are we trying to find here? We're trying to find molar mass, okay, the weight, molecular weight of the unknown. This is, the freezing point depression is 5.53 to 4.90. Okay, so let's calculate delta T. Delta T of F. So we go freezing point depression. So we went from 5.53 to 4.90 degrees C. So the freezing point went down to 0.63 degrees C. Okay, everyone see that? So if I were to draw this, we have benzene. Okay, we have 75 grams of benzene. Okay. And now to that 75 grams of benzene, we're adding 2 grams of unknown. What is the molecular weight of the unknown? Okay, so that's just a drawing of what we're trying to figure out here. And you'll do something like this in this Friday's lab, actually. Okay, so it's kind of a fun lab, a little bit dirty, but it's still fun. Okay? Dirty in the sense, you'll be crushing things, and your goggles will fog with the mask, and yeah. Anyways, all right. So delta TF here is 0.63 degrees C. Okay, so let's put it here. Okay, let's. What's K of F? So let's go back to our table here. Definitely, I'll give this on the exam. K of F is. K of F is. What is K of F? 5.12. Okay, 5.12. I'll give that to you on the exam. K of F is 5.12. Everyone see that? Okay, it will be given on the exam. So K of F for benzene is 5.12 degrees C over molal. Right, let's plug stuff in here. So we have delta T, let me rewrite this again here. Delta TF is equal to K of F times molal. Delta TF, I hope you guys agree with me, it's 0.63 degrees C. Okay, this has to equal K of F, which is a constant. We looked that up. 5.12 degrees C over small m molality. So this small m molality, what is its operational definition? Small m is moles of solute over kilogram of solvent. Okay, so that is the breakdown of small m. So we have the kilograms of solvent, do we not? What is our kilograms of solvent? Okay, I'll box it in black. The kilograms of solvent is 75 grams of benzene solvent. Let's go ahead and convert that to kilograms, which is moving it 3 to the left is 0.075 kilograms. Okay, so we have here moles of solute over kilograms of solvent. The kilograms of solvent is 0.075 kilograms. All right, so let's solve for moles of solute here. So I'm going to use this side here, solving for moles of solute. Okay, do you guys see this math? I'm going to take the 0.63 and I'm going to multiply it by 0.075 kilograms. And then I'm going to divide by 5.12 degrees C over m to isolate moles of solute. Does everyone see that type of math? So 0.63 degrees C times 0.075 kilograms, right? And then in the next step, I'm going to do 2 steps in one. In the next step, I'm going to divide it. Does people see that math?
So which one are we trying to isolate the moles from?
Yes. Well, that's what we're trying to solve for, the moles solute. Okay. So I'm just kind of do this in 2 steps. Divide by 5.12 degrees C over m. I'll just put the m here. Okay. And that is going to equal to, bless you, that will equal to moles of solute. So if you need help in going from this step to this step, you can come see me, or we can have a Zoom meeting, or we'll do something, okay? But, you know, just a little bit of math. As Adriana said, we want to isolate moles of solute. All right, so 0.63 times 0.075 divided by 5.12 degrees C. By the way, if you look at the units, the kilograms here cancel out. Remember, what is big M, what is small m, moles over kilograms. So actually, the kilograms will cancel out with the kilograms from this small m, leaving us with moles of solute. 0.63 times 0.075 divided by 5.12. I'm getting 0.00923 moles of solute. Yep, okay, thank you. Moles of the unknown, which is the solute. And now we can solve this problem, because what is the weight? What is the units of molecular weight? Grams per mole. How many grams did we add? We added 2 grams. Okay, so the molar mass is going to be, this is the last step of this problem, the molar mass is going to be 2 grams, which is what we added, divided by 0.00923 moles. And doing that on my calculator, I'm getting an answer about 217 grams per mole. That's the customary and right units for molar mass, grams per mole. And that should be our answer. Good. Right, let me talk about our final colligative property, and that is osmotic pressure. This is something that all you biology majors probably are familiar with. So you'll know more about this from biology than really from chemistry. But osmotic pressure, I want to say, is the pressure to stop osmosis. Okay. Pressure to stop osmosis. That is how I will define osmotic pressure. Again, your biology class will be more detailed and more proper. And this actually does have a relationship to biology. So let me just give you one example. Let's say we have a semi-permeable membrane. In fact, in order for osmotic pressure to exist, you need a semi-permeable membrane. And just think theoretically, let's say there's glucose here. And here I'll have blue water. A good old-fashioned H2O. So what's really fascinating about this is that totally by itself, the water molecule has some sort of intelligence. But what it wants to do is, well, this is semi-permeable. The water will rush in, okay? Will rush in to neutralize that glucose. This is something that happens in our cells, actually. Not to this extent, because our cells have transporters and whatever, proteins, all that stuff. The water, totally on its own, purely of its own volition, will go in and rush in to sort of neutralize, solubilize the glucose that's inside the semi-permeable membrane. So this next page actually tells us page 13. So let's go to page 13 here. So let me explain this again. Here is the semi-permeable membrane. Here's glucose. Okay. And here's water. Okay. And immediately what's going to happen is that water is going to rush. Okay, so water from here is going to rush this way. Okay, so look at the levels here. And then look at the levels after the water, after a certain period of time, the water will rush in to sort of neutralize this glucose. Will come in, not neutralize, maybe solubilize. It wants to get into the glucose. Again, glucose is polar, water is polar, and look at the levels now. All right, so osmotic pressure is the pressure that we must add to get back to our original state. So osmotic pressure, if I were to put a fist here, if I were to put something here to prevent this water from going in and preventing this, that is osmotic pressure. So it is the pressure, so I'm putting in a pressure, or something, some entity is putting a pressure to stop this flow and to get things back to the original status quo. So the pressure to stop, pressure, I should say input of pressure to stop this osmosis. Okay, so that is osmotic pressure. So something, some cork or something, some barrier or something, so that the levels are the same. So that this level and this level are the same. And in fact, here it is telling an external pressure applied. Okay, that's the external pressure to stop osmosis, to stop this shift of water molecules rushing towards the glucose molecule. Again, one of the things you do need is a semi-permeable membrane. Okay. Here's another drawing of osmosis. Here you see the solvent, and the solvent is rushing towards the solute to make the solution. So over time, look what's happening. This is what's called a closed system. I don't know if you remember this from Chemistry 1. This is called a closed system. Okay, totally away from the universe. So if you're totally isolated from the universe, you have this big, lid here, totally isolated from the external universe or the surroundings, the solvent will rush in and neutralize the solute, increasing the levels of the solution. All right, now for the actual math that's involved. The math is pi is equal to mRT. Okay, this pi is our symbol for osmotic pressure. I'll give you this equation on the exam. But for now, know that pi is the same thing as osmotic pressure. M is molarity. Molarity, not molality. Okay. Molarity is moles of solute over liters of solution. Okay, don't forget solution is solute plus solvent. That's our fundamental thing we learned at the beginning of this chapter. Solute plus solvent is equal to solution. And so that's m. R is our gas constant, 0.0821 liters times atmosphere divided by mole Kelvin. That will be given to you on the exam. And then T is temperature. What unit should the temperature be in? What unit should they be in? I heard it, Kelvin. Kelvin, okay? units of Kelvin. Okay, why units of Kelvin? Because it will cancel out with this Kelvin from your R. Is that not right? Kelvin. Okay, temperature in Kelvin. Right, so here's the equation. Osmotic pressure is the pressure to stop osmosis. And let's do a problem here in our last 5 minutes. We may have to continue with this on Wednesday, so we'll see how much we can get out of this. All right, so last couple of minutes or so. All right, 0.263 grams of hemoglobin is in 10 milliliters of solution. Hemoglobin is a protein found in the blood. The solution has an osmotic pressure of 7.51 torrs at 25 degrees C. What is the molar mass of hemoglobin? And we have a conversion factor here, converting torr to atmospheres. All right, so the first thing is molar mass is in molar mass will be in units of grams over mole. All right, and let's go ahead and convert this torr to Kelvin. So 7.51 torr, let's convert this to Kelvin. They tell us in the problem 1 torr is 0.00131 atmospheres. The torr cancel, and I'm getting 0.00984 atmospheres, 0.00984 ATM. All right, let's do pi equals MRT. All right, so it has an osmotic pressure of 7.51 torr, which is the same thing as 0.00984 atmospheres. Okay, equals M. Okay, we know R, 0.0821 liters atmosphere divided by mole Kelvin. And we also know T. Okay, what is T? Highlight this in orange. What is T? T is 25 degrees. So 25 degrees in convert to Kelvin is 298 Kelvin. Okay, 25 degrees C plus 273. To get to Kelvin, we add 273, and that's going to be 298 Kelvin. Okay, so let's solve for molarity big M. Okay, so everyone see this math? I'm going to take this 0.0821 times 298. I'm going to divide it. So isolating M. Divided by 0.0821 liters atmosphere divided by mole Kelvin, but the mole Kelvin will go up to the numerator. Okay, 298 Kelvin. Okay, basically what I did here was move this down here to isolate my M. Okay, now I'll have big M in moles per liter. 0.00984 divided by 0.0821 times 298. Okay, this is one unit entity. And I'm getting for molar 4.02 times 10 to the minus 4 molar of this hemoglobin. Remember, what does this really mean? 4.02 times 10 to the minus 4 moles of hemoglobin over liter of solution. Because big M is moles per liter. All right, we're almost done. We're kind of 90% of the way there. Let's finish this up on Wednesday. If you have any problems or issues, you can email me, set up a Zoom meeting. And Wednesday we'll finish this chapter. Friday we'll have a review. And have a good day, everybody.